So, good morning. My name is Bob Ward from the Microsoft Corporation. It's my honor and privilege that you all invited me here to come all the way from the United States to speak at your conference. I want to apologize to all of you if English is not your native language. Not only is it going to be more difficult for you to understand me if that's not it, but I'm also from Texas. So in Texas, our language is, people in the United States call it Texan. It's almost considered a foreign language in other parts of the United States. So I apologize ahead of time if there's some phrases I use that you've not heard of before. I think it's always interesting when you speak at a conference, people, especially people you don't know, to talk a little bit something personal about yourself. You're looking at a photograph of my younger son, Ryan, playing in an American baseball game for his high school team just last week. And he is moving on this fall to college to play baseball in America. And in fact, I would love to stay here this weekend to see your lovely country, but I must hustle back to watch him continue to play his games in the U.S. So something interesting about my family, we're big into sports and athletics, especially American baseball. So today at the keynote, I thought it would be interesting for all of you to hear about some of the reasons why customers call Microsoft support for problems specifically with the SQL Server engine. So the title of this is The Top Customer Problems, How to Avoid Calling Bob. You can blame the second part of this name on Paul Randall. Maybe you've heard of Paul Randall, famous MVP for SQL Server, and a friend of mine. And he had this idea about doing this talk, actually. And I just had top customer problems, and Paul said, no, you need to put on there how to avoid calling Bob, because having been here for 20 years at Microsoft, if you do call me and you get a hold of me, you're probably pretty unhappy. Because you've probably gone through several layers of Microsoft support at this point. As I said, I'm a principal architect at Microsoft. I've been here about 21 years, all supporting SQL Server. The first version of SQL I supported in 1993 is SQL OS2 1.1. Anybody work on OS2 1.1? Come by and share some stories with me, even if you run SQL Server 4.2 NT back in those days. All the slides and demonstrations I'm going to show you today will be available through your conference, but at any point in time, if you can't get a hold of those or if you have an issue, you can always email me at bobward@microsoft.com and I'll distribute those to you. So here are the areas that we're going to talk about today, and what I'm going to do is briefly talk about the type of problems customers call us, give some examples of what they look like, and then mostly talk about the approach that we take when you call support. A lot of this is based on internal training that we give our engineers here at Microsoft. Part of the job that I do is making sure our engineers are trained on how to do some of these type of problems. So as you can imagine, the very first area is performance. Customers saying their SQL Server has performance problems. Also, customers call saying they're having issues backing up or restoring their database. Database consistency continues to be a problem customers contact us on. SQL Server errors or exceptions, and actual other type of errors that occur in the engine. And then, interesting enough, customers contact us about that they can't start SQL Server. Now, one thing I found as I went through producing this talk is I actually looked at customer cases that people call us on, and some of these issues I was actually quite surprised on, especially this category about you can't start your SQL Server. And then finally, memory is certainly an area where people have issues where they contact Microsoft. So let's jump in and talk about performance. Certainly, many of you maybe work on performance problems, and everybody has their own way of trying to deal with SQL performance problems. I wanted to give you a feeling, based on actual quotes from customers, about what they describe to us when they contact us about a performance problem. The number one is, my SQL Server is slow. And of course, the number one question I usually ask somebody is that, what does slow mean? What do you mean by slow? The second is, my query is now slow. I have a specific query, it used to run fast, now it's changed. And then finally, I have queries that are just timing out, and I don't know what to do about them. So we have an interesting approach in Microsoft support. Performance problems present a unique challenge, and that usually, as you see here, the description is very vague. There's not a very specific issue that somebody wants help with. So we kind of have this approach that we take when we look at performance problems. We first of all see whether it's an overall server problem, or we look to see if it's a specific query problem. And one of our goals is to try to narrow down this issue to see what specific query or queries are causing the problem. Now, if you look at the category of server problems that I show up here, high CPU, I/O bottleneck, and etc., we always try to narrow these down into two categories. Is there a problem where something is running, perhaps chewing up too much CPU cycles, or are they waiting? So we try to take performance problems and simplify them into one of these two categories. It helps create a different and a simple mindset into try to narrow down the problem. And of course, if we look at a specific query, we try to see, is this query running or waiting? And of course, the goal here is to try to take an overall server problem, my server is slow, and break it down to specifically, are there queries that are slow, running or waiting that you might want to look at? Now, this is the tool set that we use when you contact us. So first of all, if the problem is happening live, in other words, you contact us and the problem is going on right now, it's currently happening, we might use a utility, a tool called Performance Dashboard Reports. Maybe you've not seen this. I'm going to show a demonstration here shortly about it. We also might specifically have you query dynamic management views to look at the problem. Now, a lot of times, though, customers might contact us and say, well, the problem happened yesterday, and it's not happening right now, but if it happens again, I want to solve this. So we might run a utility called PSS Diag. Maybe you've heard of this tool. It's a data collection tool that's going to collect rich information about your server and about queries running on your server. And then we'll take that data and we'll run it through a tool called SQL Nexus. SQL Nexus gives us rich reporting with the goal of trying to determine, is it a running problem or a waiting problem? Everything we do from a tool set is to try to break down the problem in this fashion. Now, what if we determine and we think the problem is a running problem, which is kind of a CPU-based issue? Well, number one, the very first thing I do when I look at a customer is I try to make sure it's SQL Server that's the problem. I have seen cases before where customers will contact us and it's a high CPU problem for their computer, but it's not the SQL Server process that's causing the issue. So I try to make sure, is it the SQL Server process? Second of all, I'm going to look at Performance Monitor and make sure that the issue is not high kernel time. If SQL Server is chewing up a lot of CPU cycles and the issue is high kernel time, it may not be anything to do with a query. It may be something like an antivirus driver or some sort of other kernel driver that could be causing the problem. Now, if it is SQL Server, one of the things I do look for before I start breaking things down into queries is that, is it something like a background task? For example, Resource Monitor might have an issue. I've got a link to a known bug where Resource Monitor gets in a CPU spin. Another example that I don't talk about here is spin locks. It is conceivable, and in some cases, where it's not necessarily one query, but something called a spin lock structure in our code that might be having the problem. Later today, I'm going to do a session on extended events where I actually show you an advanced debugging technique on how to go debug what's called a spin lock. That's not a very common problem, but it sometimes happens. Now, the other thing to consider here is that it could be a compilation problem. So it may not be a specific query that have an issue, but a lot of your queries are having to get compiled or recompiled. And when we have to do that in SQL Server, that could generate a lot of unnecessary CPU cycles. And then finally, it might be an actual query you're running that's not performing correctly, or a set of queries that are not performing correctly. And then when we look at query execution, there are some things that we kind of look at when we're considering, is it a running or CPU problem? The number one is cardinality estimation. Is there some sort of cardinality estimation problem going on with the query? It could just be poor index design, or it could be poor query design. I know this may seem kind of odd to you, but we do get phone calls where customers will say, I have a bad performing query, and they just forgot to put a where clause on their query. That does happen, actually. Maybe you've seen it yourself in your workplace or customers you work with. And then finally, we see queries that are running in parallel. And parallel is not necessarily a bad thing, but I always consider it an opportunity for performance tuning. In some cases, you have a query that could be using a lot of threads to run in parallel, causing a problem for your server. Now, this table is not intended to go through every single detail here, but when you look at the cardinality estimation problem that could occur for queries, there are some things that you have control over that could cause cardinality estimation. And so these are some examples, and you can look at this later in the deck, and I've got specific links for the solutions for some of these. Let me call out a couple of them. For example, table variables. If you use a table variable, let's say in a stored procedure, SQL Server always estimates that the table variable will produce one row. Well, that could be an underestimate for what you're actually really using a query for, and could cause an inefficient query plan. A second could be the data type mismatch. It's possible that you're actually querying a column on a table, comparing that to, say, a constant or a variable, and they're of different types. And if we have to do something called upgrade the type, that's a conversion that we cannot use statistics for. And so we have to make a guess on what the estimation is for your query. What if it's a waiting problem? What if we look at the issue and we say, okay, it's not a running problem, but it's some sort of waiting on a resource issue? Well, number one, it could just be a blocking problem. Maybe you've encountered that before. And when you contact us and we see it's a blocking problem, we say, hey, it's your application. We'll help you look at it a little bit further. It's probably an app issue. It could be an I/O bottleneck. We might see symptoms like page I/O latch or write log type waits. That's typically an I/O path problem. And what I mean by that is somewhere in the I/O path of Windows, your hardware, your SAN, or something of that nature. Be careful, though, that it could be resource governor I/O, which we introduced in SQL 2014. And also, in many cases, when I see an I/O issue, I sometimes try to go see maybe you're running an inefficient query where you just don't have enough cache to load the database pages you want in memory. You could be something called a latch wait, which is not necessarily an I/O problem. It could be a hot page. A very common issue is tempdb, where you're not configured tempdb properly, or you have a lot of tempdb activity, where we could have a hot latch on an allocation page. You could have something called a resource semaphore wait, which could be too many sort or hash operations or compilation memory requests. And there could be other waits that you might find in dynamic management views or in the reports that we run to look at tool sets. And then finally, a poor plan could result in these waits. So a poor query plan doesn't necessarily just have to result in a high CPU problem. It could actually result in some of these waiting issues just because of the inefficiency of the query. So let me stop for a second and do a demonstration for you that I might find interesting, specifically on this performance dashboard reports. So I've got Management Studio up right now, and I'm looking at this utility called Performance Dashboard Reports. Can you just raise your hand if you've ever seen Performance Dashboard Reports before? Has anybody used it? A few people. This is free on the Download Center, and we have a version here for 2012 that also works for 2014. There is an older version that works for 2005 and 2008 as well, if you want to pull it down. And if you take a look at this report, the first thing we do when we show you is we try to push you towards this idea of running or waiting. So if we see a problem here that looks to be like a CPU problem, we're going to show it here. If we think it's a waiting problem, we're going to show it over here on this side of the graph. So we're going to first show you, is it a running problem or a waiting problem? This report, by the way, is really easy to look at. You can look at the report definition and see we just query dynamic management views to go get actually this data. So in this particular case, I've got a query that I ran that when I run it, it chews up a lot of CPU cycles on the server. And so if you look at this graph right here, the yellow part of the graph indicates that it's an other process, not SQL Server. So if you had a high CPU problem and you ran this graph and this bar was bigger for the yellow, you could maybe go say, hey, this is maybe not be a query problem, this could be some other process, and then you have to use Performance Monitor to go figure that out. But in this case, the blue dominates, which is probably a SQL Server issue. So I can click right here, and then I can try to drill in what could be going on with SQL Server. In this particular case, what we'll do is we'll find the worst performing queries on your server. Let me try to zoom in so you can see an example here. So I've got an actual query, select star, are the Cowboys mediocre, based on a where clause. By the way, in case you're wondering, are the Cowboys mediocre, what the heck is that? Dallas Cowboys are my favorite American football team, and so I don't think they're very good, and so I create colorful names that make fun of them. So anyways, this query indicates that it's the worst performing query, and there's a where clause with a greater than sign. So if you look over to the right, you can see here, in this particular case, it was executed about 285 times. And if you scroll over further, you can see the total CPU. What's interesting, and what I normally look for when I find a query like this, is I try to see, is this query doing a lot of reads? And if you look over here, you can see it was executed 285 times, but look how many reads it was doing. This is probably an indication of an inefficient query. It's probably doing a lot of scanning, perhaps, maybe a lot of pages to produce its results. So if you're kind of wondering, well, what could be going on in this query, using these reports, you can now drill on the query and then get more information about it. I can see here some interesting information. I can see here that the value at compile time was this value, 999,000. Now, what's interesting is that the estimates, if you can see this here, look to be 152,000 rows. You can also see what's interesting, if you scroll over to the right, you can see here that I get information about the text of the plan, and I can see already in here that there's a conversion occurring right here. So I already know that in this particular query there's a conversion. And I mentioned to you before, one of the issues with estimation is perhaps a data type mismatch. Now, what's interesting about this, if you go back and look at that, I know the value at compile time is this value. Now, I built this table, and it's got like 1 million rows. So why would a value compile time of a greater than of that produce 150,000 rows? That seems wrong. In fact, I know this should produce about less than whatever that is, less than 1,000 rows, right? Why would it be 150,000 rows? Probably an estimation problem, just by looking at that alone. Now, if I go over and bring up the actual query, I can see a couple things that are interesting. This is the query that's being run, where equals this value. If I go and look at the estimated plan for it, let me go run this query to use the database. If I look at the estimated plan, I can see very quickly here this information. There's a warning that I've got a conversion. And in fact, it actually says in here that a cardinality estimation problem may occur because of this conversion. Now, it turns out the problem is that this column is a character column. And I'm trying to compare it against an integer value. And that's a scenario where SQL has to upgrade the data type to do a conversion. And in those particular cases, we have to guess on the cardinality. We don't know what it is. And that guess is like 10 to 20% of the overall table number of rows. Where in this particular case, I'm only going after a very small subset. And so if you actually would run the query this way with the actual correct constant data type, the query would perform just fine. Now, this is a very simple example. And this may not be something that applies to you. Maybe you're an expert in SQL coding and you would never do something like this. But we get calls all the time for these kind of type problems. Now, I should point out to you, when I showed you this report, I'll go back and show it to you, that the nice thing about the tool set we use, I mentioned SQL Nexus, if the problem is not live and it happens some after the fact, then the reports that SQL Nexus use look similar to this. It's the same concept of running versus waiting, finding the worst performing query. Performance Dashboard Report, SQL Nexus, those tools, the links for those are in the deck. Those are all freely available to you for you to use in your environment as well. It's not just something that only is available to CSS engineers. Okay, let me go back over here and continue on. So that's performance. Again, a very simple example, but it gives you a feel for how we approach problems, running versus waiting, and then we try to narrow down what was the query, look at the plan, use the tool sets to quickly figure out what could be the problem. So one thing that surprised me by looking at our customer data was the fact that customers struggle with backups. Maybe you do as well. I don't really know. I treat those problems extremely seriously. If you can't create a backup, you don't have a backup for your data. So what's interesting that I found is the #1 reason why customers struggle to back up their database is they're usually backing up to a network drive, a UNC path or some sort of network drive, and it's failing. And one of the errors you get is this OS error 64, network name not found. What's interesting about this is that this error occurs in the middle of the backup. So this is not a case where you put in the wrong network path or something. The backup started correctly, the path is correct, but in the middle there was a network problem. And so this is pure network issue. This has nothing to do with anything doing with SQL Server. We just simply start writing bytes to a file path, and that file path on a network, if a network issue occurs, this is the error we get back. One issue I have seen is this something called TCP offloading caused this problem, and you can go in and read the resources about how to address that. Another is OS error 1450, another scenario when you're backing up to a network drive. And this is caused by OS memory problems. And what I mean by that, there's something going on with Windows where there's not enough what's called non-page pool available to Windows. Now I say that because when we back up to a network drive, we have to use the file system cache for Windows to do that. So I've seen scenarios where customers are backing up very large databases to network drives, and this is the error they'll get. And in this particular case, this is again a Windows problem to try to resolve, not a SQL Server problem. Another one that may seem simple to you, but is something that's actually extremely common, is somebody calls and says, my transaction log continues to grow unbounded. It grows and grows and grows and grows, and it never gets any smaller. It never gets truncated. And the reason is that you're using a full recovery database, but you never back up the log. And so actually there's a product that I've worked on called System Center Advisor. It comes free with System Center, free download if you don't even have System Center. And there's a set of rules in there that CSS has created to help you detect things on your system. And one of them is to look for this. We look at your backup history and say, do you have a full recovery database where you actually didn't back up the log? And then finally, you can have something called a virtual device interface backup failure. If you're using a third-party program like, say, Redgate SQL Backup or another third-party backup solution, they use something called VDI, or Virtual Device Interface. This is a protocol that they talk to SQL Server to do a streaming backup. And I've seen cases where errors occur in the error log due to a VDI application, but almost every scenario, it's the VDI application that has the problem, not SQL Server. What about restores? So restores running slow is a very, very common issue that we get. Could be a disk bottleneck. It could be that recovery is just taking a long period of time. You know, when we restore a database, we have to go run recovery on it. So depending on when you backed it up, we may have to go do a lot of roll forward and roll backs of transactions. And if that takes a long time, that's part of the restore process. And then probably the most common reason is virtual log fragmentation, virtual log file fragmentation. And we've got specific support advice in an article if you run into that on how to resolve that. It could be that the media is corrupt. So I don't know how many of you use actually the with checksum option for backup, but I highly encourage it. And the reason is because when you back up a database with the checksum option, we will first verify the checksum of the pages that we're backing up, and then we will write a checksum value in the backup media so that when you use restore verify only, we will see if the media has been corrupted itself using this checksum algorithm. And then one thing you may or may not be aware of, if you do a restore and it's having a problem, you might be able to use the with continue after error option to get past the problem and at least bring the database online and then try to repair from that point of view. Now, one of the most common mistakes I see customers make is they try to restore a database on top of an existing database. And you may think that's not normally a problem. And of course, if the restore works, it isn't a problem. But what if the restore fails? If you restore on top of a database and the restore fails, it is very likely you cannot get back the original database. So, customer calls us and says, I'm restoring my database, it fails, I don't know what to do. And we're like, well, did you have the original before you restored? And they're like, no, I restored over it. Well, at that point, we can't help you. We try to go repair what you have, but we can't actually get back the original database. And then finally, in some cases when you restore, you might try to go rebuild the log with emergency repair or something. And just be wary there that that can lead to data inconsistency problems, even though CheckDB is clean. So let's show you a brief example here of something that you might find interesting. I have a database here. Let me shut this down. I have a database over here called Bears Win the Big 12. Sorry, more colorful American sports names. So I went to a university in the United States called Baylor University, and their mascot is the Bears. And so the Big 12 is the conference and where the Bears play their American football games. And so I have this name called the Bears Win this conference, right? I'm sure you're going to go back later and go, who is this crazy American with all these really bizarre names for databases? So I have a backup called Bears Win the Big 12 in this directory on my temp drive. And I backed it up earlier. And so what I want to do is I want to go ahead and just try to restore, do a verify only on that backup. And if I do that, notice I get this error, damage to the backup set was detected. Now what's happening here is that SQL Server detected a checksum was written for this backup media, and now it says it's invalid. And so now I know there's a problem here. And in fact, if I actually try to go restore the database itself, this is what I'm going to get. I get a little bit more information. And what I get here is that the restore detected an error on a given page. Now, I should tell you that what I did was I backed up the database, and then I went into the database backup file with a hex editor, and I scribbled on top and I damaged my database, kind of simulating a disk failure where my backup restored. And so I damaged the media, but since I used the with checksum option, SQL Server was able to detect that there was a media problem. Now you could, if you want at this point, try to use with continue after error as a workaround to say, well, can I get past that problem? And that's possible. We'll run it and see what it does. And it worked. Except, notice here it said there was a damage to the backup set, and it said you use this option so it's successful, but some damage was encountered. So you could run checkDB at this point to see what the problem is. I happen to know, based on what I damaged on the database, that I actually damaged a system table on purpose, just so you can see this. So this is an example of the ramifications of this problem. So if I use this database and run this query to look at my stored procedures, I get back a checksum error. So it's an example where you might contact us. We might help you use this option to get past your error, but there's still damage that you have to deal with. In this particular case, my stored procedure system table is damaged. So what would you do in this case? Well, we would help you just try to copy out your data and say that we cannot recover your stored procedures at this point because there's nothing we can do. We can't patch necessarily the database in this particular case for this problem. So quick example about some of the features. I highly encourage you to look at backup with checksum as an option in your environment. I have found personally from talking to customers that the overhead for that is not all that expensive compared to the benefits of what you get for it. So what about database consistency? I'm sure none of you have ever had a corrupt database before. You've never had to worry about it. But it happens, right? So what are the symptoms of a database consistency problem? Number one, this message 824 error could occur, like you just saw when I did the restore. And typically, it's in the form of a checksum error. And I'll show you an example of what checksum means here in a minute. You could get errors from DBC checkDB. That's possible. You run that command and see that. But what you may not recognize is that you could get something called an assertion, access violation, or a hang of SQL Server. If you have a corrupt database, we don't build the SQL Server code to detect every possible corrupt bit in a database. So it's possible you'll get some sort of really strange error from SQL Server if the data that you have in your database is damaged. Specifically, if the overhead structures to describe the page or the row or something may be damaged. You also could have a database that gets marked suspect, or this concept called deferred transactions. I should point out here that Paul Randall, I think, does a very, very good job of doing really good blog posts on how to recover from various situations and how to describe how to look at database consistency problems. So if you contact Microsoft support, what do we do in these cases? And I want to kind of break down some myths about what we do and don't do. Honestly, we only do really these three things for you. We help you restore a database backup. We'll try to help you repair the database, if that's possible, using like checkDB with repair commands, or maybe just help you extract the data out. But that's it. We do not have magic repair tools at Microsoft to help you go just fix your database with just a little wave of our hand or something. There's nothing exists like that in our company. We don't build tools like that. We're not even a data recovery company. Now, we want to try to help you. Now, I would say, with a caveat, that if we think it's a bug with Microsoft products, with SQL Server, I personally will go to the ends of the earth to help you fix your data. But that's a very rare scenario. Most of the time, it is something to do with a hardware type problem. But those are the kind of type things that we'll do, and we don't really do anything more than that. So I thought you might find it interesting, as part of this conversation, to understand how our checksum algorithm works. Because if you do run into a case where you get a checksum error, I want to show you why I believe it's going to be definitely an I/O problem or a hardware problem and not a SQL Server problem. Now, this little diagram in here is a very crude drawing of a database page in memory. At the top is what we call a page header. And so it's page 100 with these fields called torn bits and flag bits. You don't even know what those are, but I'll describe to you how it's important in the checksum algorithm. And here's my crude rows. I have 2 rows, one with some numbers and one with some characters. Now, if your database has the page verify checksum option on, here's what happens and what SQL Server does. First of all, if your page is written to disk with a checkpoint or lazy write type operation, what we'll do is we'll calculate this checksum, which is a mathematical operation. We'll calculate this checksum. We'll mark in this torn bits field the actual checksum value. And in this flag bits field, we will mark the fact that your page was checksummed. So we know that this page has had a checksum calculated on it. Now let's say that at this point, we calculate this and we write the page to the actual disk. In this case, mavsrule.mdf file. That's the database file. When we read your page back from disk, here's what we do. You maybe can imagine kind of what the scenario is going to look like here. We take a look at this page. We recalculate the checksum. We take a look at the page, we read it in, we run our algorithms again to calculate what the checksum value is. And then we're going to compare the checksum we just calculated with what's stored in that page header in the torn bits field. And if they're different, that's a problem. Now what we'll do immediately at that point is we'll mark in something called a buffer structure in memory that there was an error, error code 4, which means a checksum failure. And then when somebody needs this page, say when they latch this page, they will get this error 824. So you can see by this algorithm that the only way we would get a checksum problem is if something altered the page between us writing to disk and then turning around and reading it from disk. Now what you may not know is that we actually do have behind the scenes a read-retry algorithm for these problems. So when you get a checksum error for 824, we've already attempted to try to retry it 4 times. And if it fails after the 4th time, we will then actually surface the error. If we did a read-retry within those 4 cycles and it worked, we will actually print a warning that it worked in the error log. So how could something like this actually happen? What are some of the causes we see when somebody calls and has a consistency problem? Number 1, I mentioned this word I/O path is the number 1 cause. And this is based just on actual case data from customers contacting us. And again, this could be anything from drivers on Windows, it could be Windows itself, it could be hardware, SAN, you name it. We have a utility that you may have seen before or heard called SQL IOSIM. It's an independent utility of SQL Server, but it simulates the I/O patterns of the engine, and it can be used to help detect consistency problems. And in fact, the tool produces some of the same errors that the engine produces when it detects consistency problems. The second could be memory corruption. And we actually have an algorithm called constant page sniffing. I realize that's a funny word. Where we actually do that checksum algorithm while pages are dirty in memory itself. And we produce a specific error for it. One interesting side effect of memory corruption problems, though, is if a constant page sniff hasn't detected a problem, the checksum algorithm actually doesn't work. And here's what I mean by that. If the page is damaged in memory before it's written to disk, the checksum is going to be based on damaged data. So if it actually occurs in memory and not on the I/O path, we won't know why it's damaged, which is a reason why CheckDB is still a valuable tool for you to detect consistency problems. And then finally, I realize there's no way this could ever happen, right? But there could be a bug with the product. And one little tip for you that I use to help customers disprove whether we have a bug that's causing something like this is to replay the transaction log sequence. So if you have a database backup that you know is clean, in other words, the backup is free of any consistency problems, you could restore that and then restore a sequence of transaction log backups that cover the time that the data became damaged. If you do that and you get the same consistency problems, maybe there's a logic problem that is surfaced by replaying the transaction log. So that's a very, very simple technique that I use all the time to detect if there are issues. Let me show you a quick little demo you might find interesting about how to recover from data. That's true. I think my father uses that technique here. Okay. So let's get rid of that. Let's get rid of that. Okay. This is a little bit of a tricky demo. We'll kind of cross my fingers this one's going to work. So I have a database called the NBA Playoffs. Sorry, more sports. And I have this table in here about the Dallas Mavericks, which is my favorite team. So they're playing right now in the playoffs. What I'm going to do is I'm going to go ahead and create a table in there, insert a value. I'm going to checkpoint. I'm going to run a checkpoint because I want to flush to disk the changes I just made. I'm going to back up the database. Then I'm going to go in and I'm going to run a transaction and insert another row in there. Okay? And that looks like that all worked. Now I'm going to do something really interesting. Yeah, I'm going to go ahead and checkpoint again to make sure that's written. Now what I'm going to do is I'm going to use a system table to figure out what page did I just change. And by looking at this data, I can tell you that the page on the database is page 288. Now I'm going to do something that I don't recommend you do in production, and that is I'm going to kill SQL Server without shutting it down. See if I've got Task Manager. I think I've got it right here. So I'm going to go find the SQL process. And I'm going to say in task. And I'll explain why I'm doing such a crazy thing. Now, the other thing I want to do is I want to go calculate in hexadecimal. This is something you do all the time, I'm sure, calculating in hexadecimal. What is the value of 288? So 288 in hexadecimal is, I want to take this number 288, I want to multiply it by the size of a page, which is 8192 bytes. Each page is that size. I'm going to multiply it by that value, 8192. And I'm going to come with this number, and I want to see what that is in hexadecimal. Now here's why I'm going to do that. 240,000 is this number. I'm going to simulate what happens if the I/O path causes a problem. I'm going to go over here. I'm going to use this editor I have, this list program, and I'm going to go to 240,000 in the page. Now you can see here, I mean, you don't normally do this, and I don't expect you to, but I'm simulating a disk failure here. So I'm going to go inside this page, and you can see over here to the right, here's my string of my row. And I'm going to do just like, I'm just going to go scribble on top of it with a bunch of this. I'm going to save the changes, and then I'm going to restart SQL Server. Remember, I killed it. So I'm going to start it back up. Now what I'm going to do is I'm going to go in and I'm going to run a command, a script that's going to try to truncate that table. Well, first of all, what I'm going to do is I'm going to say, is the database online? Just to prove myself, it is online. Then I'm going to try to truncate the table. Now you notice here that the truncation appears to be hung. Now why is that? So it appears to be blocked at this point. If I go over here and I look at something called a dynamic management view, I can see what's going on with this truncation. I can see that the truncation over here is suspended. Excuse me. Okay, it's like a blocking problem. Well, who's blocking it? If I go over here, I can find that the blocking session ID is -3. What the heck is a -3? I mean, there's no user with -3, right? And it is waiting on a lock. If I go over and look at a database management view for locks, I can confirm that sure enough, there is a resource, this page 288, that's being blocked, that -3 owns it. Page 288 being that resource. So what's going on? Well, one thing I could do here is I can look at this database table in MSDB called suspect pages. Anytime we run into a page that has a consistency problem, we record it in this table. And sure enough, I can see here that page 288 has actually been recorded in there, like right now, as a problem. Okay, so now I know I'm blocked with this -3. I've got this problem, this 288 page is part of this blocking problem. What is really going on? So what I'm going to do is I'm going to go look at the error log file. And if I come down here after startup, I'm going to find some interesting errors, specifically around here. Okay, notice this message here. Errors occurred during recovery while rolling back a transaction. The transaction was deferred. Restore the bad page or file and rerun recovery. This is a good example where SQL Server has done something very interesting. We ran recovery on the database. We detected the damaged page. But what we're able to do is hold up locks on this page. so that no one can touch it. So that's called deferring a transaction. So we've avoided any consistency problems by anybody touching the page, but we're able to bring the database back online. So you're free to use the database as long as you don't touch that page. Well, how do you recover from this? Well, it says right here, restore the bad page or file and rerun recovery. Well, we've got this feature in Management Studio to help you do this. And we get pretty smart about it. So here's my database. If I click on here and I say restore page, I get this window. What I want you to notice is very interesting. SQL Server has already brought up page 288 as the page it thinks I should restore. Now, how did it know how to do that? Well, it detected in the suspect pages table that this page for this database was damaged. It already knew that and says, you probably want to restore that one because I just detected that that was suspect. The other thing that's interesting here is that it knows my backup history. It knows that I've already backed up the database and the transaction log, and it knows where they're located. So if I simply say here, this looks fine to me, why don't you do it, it actually restores it successfully. If I go back over to my truncation, it's now completed. So it's a great example of SQL Server detecting a consistency problem, allowing the database to come back online, simply blocking you from touching that page. Now, with these simple commands, you could restore the page, unfree him, and you're completely back up online. Pretty simple, easy thing, and this is something I would walk through with a customer. If they had this situation with this deferred transaction, I would tell them it's a consistency problem, and we could maybe just simply restore the page to get you back up and running. But the key was I had a backup set that covered this range that was clean that allowed me to do that. Now, you're not going to go use this editor to go damage pages in memory, obviously, or on disk. I was just using that to simulate what happens to a database page if it's written to disk and then it becomes damaged, and then if recovery has to access it. And if you're wondering, why did I kill SQL Server from the Task Manager? I didn't want SQL Server to go checkpoint or record my change I made that was an uncommitted transaction. I didn't want it to roll back that transaction, right? So I wanted the transaction log to think it needed to roll that back and touch the damaged page on disk. So, small little interesting demo for you of how that works. Any questions so far of anything that I've covered on this or so far on the topic? Either you're just getting going awake or you're not sure? Okay. Okay, so has any of you, raise your hands if you've ever had a SQL error log that has something like this in it before. Unfortunate gentleman in the back right there. So what is this thing if it shows up in your error log? What exactly is SQL Server doing? Why is this a problem? And why does you get calls on this? So what happens is in our SQL Server Engine product is we detect certain types of problems called exceptions. And when we do that, we produce something called a stack dump, which is this information in the error log and a file we write out called a mini dump file. So if you look at what we produce here in the error log, it looks pretty strange, but there's some interesting information that could benefit you. Number one, if you look at something called the module, that's the actual DLL or executable that had the problem. If that says SQL Server or SQLDay or another DLL that's part of the SQL Server product, then the problem is probably ours. Probably a bug going on with SQL Server. But I've had customers that have these stack dumps where that module name says Oracle. Oh, did I say that? It's true. It's true. Actually, ORA32 is a DLL of theirs. And if that has that problem, in this particular case it was a link server query, the issue is with their DLL, not with SQL Server. It's more often than not that these come up with a SQL Server module, but that is possible, so you should check that out. The second is, what is this exception code? If you were to call me and say, hey Bob, I got this stack dump in the error log, what do? I would say, what's the exception code say? And if it's exception access violation, very unlikely we've just accessed an incorrect memory location in our code. And then second of all, this input buffer is very interesting and very helpful to us. That is the query that was running at the time of this exception or this access violation. I may ask you, can you just run that query again and see if you get the same problem? And if you can, you likely have a very easy reproduction of this problem that you can actually send me. The other thing I'm going to ask you is to send me this file, this mini dump file, and the path for that location is recorded in the error log. You send me that mini dump file, I can pull it up under what's called the Windows debugger and perhaps figure out what the source of the problem is. So there are other errors that customers contact us on that may not be obvious to you on how to solve them or how to approach them. Now, many of you know what deadlocks are, and you probably work with those all the time. But what you may not know is something called the system health session records these by default. You may use a trace flag today. Typically, it's trace flag 1222 to go get a deadlock graph and figure out the deadlock problem. But you don't have to do that anymore. In SQL 2012 and later versions, the system health session is actually recorded to a file all the time. So you could go have a deadlock in your server, bring up the system health session, which is an extended event session, and see the source of the deadlock and try to resolve the problem. I will tell you that 99% of deadlocks that people contact us on are application problems, and we'll help you work through those, but it's generally not an issue within SQL Server Engine itself. Another one is an I/O delay. An I/O delay warning. And the message in the error log looks something like this. SQL Server has encountered X number of occurrences of I/O requests taking 15 seconds. Can anybody in the room tell me what the average seek time of a decent disk is to get data? I'm sorry, can you yell that out loud? 10 milliseconds? That's probably slow for an SSD drive, right? We're saying here that we've detected an I/O that we read or wrote to disk took 15 seconds or 15,000 milliseconds. So this is a very severe problem. And so if we actually detect this in the error log, we're going to tell you, hey, I/O path might be a problem going on in your system. You know, let's go look at that. We might run the SQL I/O sim tool we just mentioned to see if we can detect an issue. Now you should know that one of the most common disk performance counters that people use is average disk seconds per transfer. That's where you might see this disk seek type millisecond range. If this I/O occurrence happens very infrequently, this is an average disk performance counter, and it actually may not show the problem. Normally your average may be very good, but you may have one sequence where this is an issue. You may be asking, well, what could cause something like this? I've seen all sorts of problems here. I've actually seen antivirus drivers cause this. But more than often than not, it's a SAN issue, something with your SAN or your disk that's going on that causes this. So this is SQL Server simply detecting there's a disk issue going on from a performance perspective. Another type of really, really strange error that you may never seen before is called an assertion, which I call a poor man's error, because it's just an error in the error log that produces a stack dump with a very strange expression in it. And I'll show you an example here in a second. You might run something called a non-yielding scheduler error if you set up your error log. This is usually something to where there's a problem in our scheduling system where a given thread is not switching properly and causing an issue for what appears to you like a hang for SQL Server. In addition, a deadlock scheduler is a very similar type of problem that's like a non-yielding problem, except in this case it's typically a very long blocking chain. So for example, if you run queries in SQL Server and all of your workers are blocked on a resource, all the worker threads are consumed with blocking, you will literally hang the server. You cannot run connections or queries at that point because all of our threads are busy waiting on a resource. You could use something like dedicated admin connection to go in and maybe free the problem, but in that case you might get this error that's a deadlock scheduler. And then finally, for latching problems, which could be I/O issues, if it takes a really long time, say 5 minutes to get this latch, you will get something called a latch timeout. All of these situations here are kind of unusual errors, but we actually get calls on them. And one common theme for them is they all produce this stack dump I just mentioned in your error log. And in the header of the stack dump is the indicator of what type of problem it is. Now finally, if you are running into errors with SQL Server and maybe something shows up in the error log that you're not sure what it is or what query encountered it, because maybe we recorded it in the error log, but your application didn't log it, and you just heard the user say, oh, I got an error. And you're like, well, what query caused this error? In the extended events feature we have, there's an event called error reported. You could actually set up a trace of that event, and you could actually capture what query or other details about that error. So anytime you're dealing with an error that you're not sure what it is, you could use this extended event to go capture more details. So, so I love these kind of things, funny things put up there. So I have this quote that I used back at Microsoft called "I love errors." You may think that's kind of a strange quote to make. But the reason I say that is because as opposed to a performance problem, an error is a very specific condition in our source code. You know, when I see an error like this 833 IO delay, I know exactly what causes that kind of error. Whereas a performance problem is a very vague description like my performance is slow. So I want to just show you really briefly here what one of these looks like. And I'm just going to show you an example of error log. So if you start scrolling down here, you're going to start seeing this stack dump type behavior. Here's begin stack dump. Now if you notice here, what's different from the other one I showed you on the screen is here's that input buffer, but notice this part here does not say exception access violation. It has this funny thing called a location and expression. And as it turns out, that's actually a location in our source code where this error is detected. If you were to get something like this, and it's the first thing that shows up in the error log, you probably need to call me. This is a I can't avoid calling Bob situation, and we'll have to go look and see what the problem is. I want you to notice, though, that for this problem, SPID51 is the one having the issue. If you scroll down, there's another stack dump that shows up even later right here, also for SPID51, and that is an access violation. This is a good example of a problem caused by a problem. So if you get a lot of these stack dumps in the error log, if several of these occur, always go to the top and find the first one that happens and see what's going on there. Another thing I should point out here, as I mentioned earlier, a database consistency problem can cause this behavior. And that's actually a true story. So if you get things like this, one of the things we may ask you is, do you have any errors for consistency's sake from your databases? We'll ask you to check that because it's possible that if you have that going on, we can get these type of strange assertion errors. Okay. So I was really surprised when I read our case logs and looked at our case studies that customers struggle with the fact that they can't start SQL Server as often as they do. I was kind of surprised by that. And so some of the things I found were very interesting. The number one reason why people cannot start SQL Server that they contact on is a permission problem. And here's what I mean. If the account that's running SQL Server service does not have permissions to the registry, the folders for the databases, the error log file, or the system databases, you won't be able to start SQL Server. But you may be asking yourself, well, why wouldn't the service account have those permissions? Well, what we found is that sometimes customers will report to us their server had a hard restart, like there was an unexpected restart of the computer. And we suspect there's something that happened with a service account change that could have occurred that could cause this behavior. It could be a configuration problem. If you go in and try to change the parameters for the SQL process, like adding a trace flag or something, prior to SQL 2012, you could easily make a mistake doing that. In 2012, we actually have a full editor that's a line-by-line editor for adding parameters to the SQL process. You may have set the max server memory configuration value too low. That's a mistake I've seen customers make. If you set it to a really low value, it's possible the server won't start. And in those cases, you could actually use the -f parameter to do minimal startup of SQL, which will temporarily allow you to fix the problem. And then finally, if you use this feature called lock pages, it requires contiguous memory, and it's possible SQL won't start because it doesn't have enough memory to actually acquire to run the engine. This is a very interesting problem that I've seen. Customers contact us and tell us that the system databases or even the actual installation executables have been damaged. The SQL Server XE or DLLs or other files have a problem. And so without getting into the causes of why that occurs, what I find interesting here is that people really struggle to recover from those situations. So one little tip for you is for system databases that don't change often, maybe you don't change master very often, you probably don't even change model very often, I recommend you keep a file copy of those, not just a backup of them. Because quite frankly, in my experience, it's faster for model to simply shut down SQL Server, copy over the model files, and just restart it, versus trying to restore a backup of model. So if it doesn't change very often, then I just recommend you do that. And then certainly for the installation executables, keep your media in reach. Many customers contact us, the executables are completely damaged, and our answer is you've got to reinstall SQL Server. But if you've got the media, you can maybe just copy over the executable from it and you're back up and running. Now obviously, if you install service packs or hotfixes, you'll need to back up those executable files accordingly, but that's a little tip for you that might help you recover quite quickly. And then finally, there's this really bizarre scenario where you might back up the tail of the model, tail log of the model database, and all of a sudden you can't restart SQL Server, and I've got some guidance for you why to avoid that and then how to actually get around that problem. So let's end our conversation talking about memory. Number one reason why people call us about SQL Server memory problems is they claim there is a memory leak in SQL Server. And they will show me a perfmon chart that looks like this. And I will tell them that is not a memory leak. So many customers are used to seeing processes that they work with that when the memory just simply climbs up like this, it's a leak. But for SQL Server, this is normal. It's normal for us to dynamically grow our memory allocations until we reach something called a target. And if you look at this slide right here, you'll see two counters, a target memory and a total memory counter. If what happens is the total memory counter exceeds the target and it keeps climbing above it, now you might have a point. And you can contact me and we'll talk about it, right? But that's usually not going to happen. And in fact, a leak within SQL Server will actually not result in something like that. It'll usually result in an out-of-memory condition or an out-of-memory error. So again, number one reason why people contact us is they think there's a memory leak, but this type of behavior is normal. And what will happen is in a graph like this, it'll eventually reach a plateau, which is the target, and will just sit there and will flatline underneath our floor, our ceiling, which is the target of our memory allocation. So here again are the other reasons why people contact us. They say my memory is growing, my memory is leaking. Those are the kind of comments I get. This is another interesting call we get, is that people will use Windows Task Manager and they will say the memory that it shows does not reflect the memory that I've installed. For example, I've got a computer with 32 gig of memory and SQL Server should be using all of that memory, but Windows Task Manager says SQL Server.executable is only using 100 megabytes. What's the problem? And my answer is usually you're using something called locked pages, which is a normal behavior a lot of servers use nowadays. When you use this locked pages feature, Windows does not know a lot of the memory you're allocating from a task manager perspective. And you've got to go look at SQL Server performance monitor counters or SQL Server dynamic management views to see the true accuracy of what memory you're using. You might have scenarios where the cache keeps growing out of control or your planned cache keeps dropping or getting evicted. And in those particular scenarios, it's usually some sort of performance problem where some other type of memory is consuming so much that the planned cache will get evicted. I mentioned about you may set max server memory that's not accurate. This has actually happened before, and again, you can use -F to get out of those scenarios. Somebody may say that actually memory is actually being consumed too much by somebody, or that you really think there was a leak. There's a concept called a memory clerk. And a memory clerk in SQL Server kind of describes what type of memory is being used, whether it's planned cache or compilation, or maybe you're using CLR, full text, XML, various features. These memory clerks help describe what type of memory is being used. And if you look at them, you can find what is the highest memory consumer and why could that actually be happening. And then finally, you might have blocking problems. You could actually have a contention problem going on in SQL Server. That's a blocking issue caused by memory. For example, I mentioned earlier when I was talking about performance that a resource semaphore wait is caused by very high sort and hash queries being run. You could have a very, very large sort operation in SQL Server based on your query plan that could result in a lot of sort memory being used. And if enough of those are run, you'll get blocking on this resource semaphore. And the reason because of that is we don't want to allow too many sorts to run that take over the entire server. The same thing goes for query compilation. If too much query compile memory is being used because you're compiling a lot of queries that take a lot of memory, we may gate you with this wait type resource semaphore query compile. And then finally, you might see this wait type cmem thread could show up. And if that actually happens a lot and it becomes an issue for you, it could be actually a scalability problem, and that's where you may need to contact us. But you can also look up on our blogs. There's good information here about things you can do to help resolve issues even without contacting us. I'm not going to go through the demo here. The simple demo I have for you is showing you a query that consumes a lot of memory and then adjusting max server memory to see the actual eviction and see the fact that we don't leak memory as we actually grow up and hit a target and actually come down. So let me just review some things for you that we talked about today. I apologize that the lines are cutting some of my words here, but let me just review for you. So in performance cases, I really want you to think about this very carefully as you work on these problems. Always think about running versus waiting. Is it a CPU problem or is it a blocking type or a waiting problem? And then try to narrow down at that point. And always try to go down and narrow what query could be causing it. I highly encourage you to check out Performance Dashboard Reports, which is a report you can run in Management Studio for free, and SQL Nexus, which is a tool you can run offline for a more bigger collection of problems. Operating system errors seen during backup are usually not a SQL Server issue. We're more than happy to help you in support, but generally we're going to point you to some sort of issue with your network or something like Windows memory. Use the backup a checksum command. It'll help you greatly when you have issues where you're trying to restore a database. And then think about it, if you use this option and you constantly do a restore with verify only, which is a very fast operation, you can detect very quickly, are your backup medias being damaged or are there any problems with them before you get in a sequence where you'll actually need to restore it. Recovering from corruption is either restoring or repairing. There's no other magic other than doing those two things. Deadlocks capture with a system health session. Keep backups of those system database and media files. And finally, SQL Server memory just growing over time and then plateauing is not the sign of a leak. I have some good resources for you. I think the escalation blog that my team runs is actually very valuable. A lot of great information up there. I mentioned Paul Randall's blog as well. I hope you found the information helpful today. I'm going to be here at the conference the rest of the day today and tomorrow. I actually love meeting people, so I encourage you to come up and come meet me and ask me about things I talked about today or any other interesting thing about SQL Server or maybe about American sports. I'll certainly love talking about that anytime you want. So I appreciate your time today. Enjoy the rest of the conference. Thank you.